Good morning, ladies and gentlemen. I hope you're sitting down, notebooks out, ready to take notes. Today we're going to look at simultaneous equations. Now, simultaneous equations are essentially when you have a Cartesian plane and then having two lines existing simultaneously on the Cartesian plane. And remember that equations for a line can look like a variety of different things. You might have a pair of equations looking like that, or you may have a pair of equations in general form like that. Either way, each one of those equations describes a line, and they both exist on the Cartesian plane at the same time if they're simultaneous equations. Now, with two lines on the Cartesian plane, there are three possibilities of what could happen. Firstly, and most commonly perhaps, is two lines like this that meet. They have a unique intersection. So the solution to this pair of Cartesian equations, if you like, is an xy point where they meet. Equally, it's possible to have a pair of lines on a Cartesian plane that are parallel and therefore have no intersections. Finally, it's possible to have a pair of lines on the Cartesian plane that are in fact the same line. This means they have infinite intersections, or the lines are coincident. So those are the three possibilities when we have a pair of lines on the Cartesian plane. So how do we find where they meet? Or if they're parallel, how do we find that out? If they're coincident, how do we find that out? How do we approach two lines in the same plane? And there are three ways to do it. One graphically and two algebraically. Now in year 9, you will have done essentially a lot of graphing of straight lines by hand. And we will do some practice in class, but you could imagine if you draw a really accurate graph, that you could plot two lines on it and have a pretty good estimate of where they meet if your lines are very accurate. Good news for us is we can do this even more accurately using the CAS calculator. So I'll show you how to here, and we will plot a pair of equations on the CAS. So in our CAS main menu, we go to either press B and into the graph page. Here, press tab, and I believe I showed you this before, so I'll be very quick. Say 2x plus 3, one line. For another line, you can either double click the space or press tab again, minus 3x take 2. Line meets somewhere, find their intersection, like so. Menu, analyze graph, it has a picture of intersection there for you. Intersection, lower bound, upper bound either side, it is intersecting at -1, 1. Now what that means is that when you sub in x equals -1 into both equations, the y will have the same output. So let's look at that here very briefly. Alright, so remember the intersection point was x equals -1, y equals 1. That means that if we sub this x value of -1 into either equation, the y value should result in -1. Sorry, +1. So let's check that. Two lots of -1 plus 3 is indeed +1. Here, if we sub in -1, we have -3 lots of -1 minus 2. That's the same as 3 minus 2 is equal to +1. Alright? And that is the only value for x for which that works. So if you subbed in x equals 2 to both equations, the y equals result would be different. It is a unique solution. So there's only one answer for x here. That is the only point on the Cartesian plane where those two lines meet. Right. In your OneNote, using your CAS, and if you're very clever, you can take a photo of your CAS and stick it on the OneNote to show me how you've done it. Can you find the intersection of those 2 points? Bear in mind, to enter it in OneNote, you may need to rearrange them. Sorry, to enter it in your CAS, you may need to rearrange them first into slope intercept mode. Thank you very much.